Right, okay, so yeah, I'm Mark. Anybody who doesn't know me, I don't know what I do either, so there's no point in me explaining who I am. I put these on my gear set slides because the boss told me I had to, so that's who I work for, and we are hiring and the rest of it. But anyway, I'm going to talk about serverless node without lock-in. And I think what I'll be basically covering is why you should care about serverless node without lock-in, and a couple of things called KEDA and DAPA, which help you to achieve that. Right, so why do you bother? If you've done serverless development, you'll know that, particularly if you're doing, when you're doing your local dev, it's not quite full fidelity. So you can sometimes find that because you're essentially running an emulated environment locally, that you're not getting the same experience as you will when you actually deploy it to your cloud serverless environment, which, yes, has been known to cause a few wee problems. It's a slight problem in that, normally with serverless stuff, at least with the proper serverless stuff, you can't run your functions, your individual functions, for more than 5, 10, 15 minutes, depending on what platform you're running on and how you got it set up. And the main one that is the one that people always come up with, or at least the management always come up with, is they don't want to be locked in. They don't want to be tied to Lambdas or Azure functions or Google Cloud functions or any of the others, because then they'll have all that terrible stuff going on of what if they bump the prices up and we're stuck on that platform, or what if something goes wrong, which is why everything these days seems to run on Kubernetes, because Kubernetes can really sort of run on anything. So just quickly, what we're thinking of is serverless stuff here. So a serverless system, usually there's a pile of messages or something. There's a workload that you need to work through. Now those might be HTTP requests, they might be messages on a queue, they might be things coming into a database, might be SMS messages, but whatever it are, they're coming along, and there's between 0 and very, very many of them. And what a serverless system will do is it will have some sort of thing that's there to process these messages. So web server, or sort of pulling in the messages and doing something. And depending on how much work there is to do, it will automatically scale up and down, the number of instances that it's got processing all those things, and then it will go off and do something and update whatever other stuff you've got running in the cloud is. So the way we can do this without having to use sort of a locked-in serverless platform is to build it on Kubernetes. And then we add these three things: virtual kubelet, KEDA, and DAPA. So the first thing is the virtual kubelet. All that means is that rather than having it on actual VMs under the covers, you're running it in whatever your cloud's container running platform is, so Fargate or container instances or whatever. But the basic idea there is that you make a virtual VM, which is essentially an infinitely scalable virtual machine, and can run as many containers as you want at the same time, or no containers if you want. And generally speaking, will only be charging you for the amount of time that those containers are running and the number of them that there are. So Kubernetes is normally designed to run on actual VMs, but with the aid of virtual kubelets, then you can actually run it not on VMs, but just purely on a container infrastructure. What you then have is a thing called KEDA, which is the Kubernetes event-driven autoscaler. What that essentially does is to look at your workload, look at the size of your workload, and automatically scale your kubelets, your virtual kubelets, to give you the number of containers you're going to need to actually chew through all that work. And then the last thing is a thing called DAPA, which is, again, something you can plug into Kubernetes, and it allows you to very easily connect your workers to the workload that they need to pull from. So just going through what those are, KEDA plugs into the normal Kubernetes. Now, there's a little bit of scaling built into Kubernetes if you want, but it's more based on CPU and memory. What KEDA does is it actually goes and looks at your, what it's called the external trigger source. So that's your workload, and it adds itself into Kubernetes in such a way that, as well as scaling, with using the normal horizontal pod auto scaler, which can go from 1 to many, it also adds the ability to scale right down to 0, which, if you're on the right platform, means you're not paying anything, and it will, sort of hook into the pod auto scaler so that it can scale up, sort of as many of your pods as it needs, as many of your containers as it needs to work off that trigger source. Just taking this little scaled object configuration here, which looks something like that. So once you've got Kida installed in your Kubernetes cluster, then all you need to do is to give it this bit of configuration, essentially telling it what it is that you want to scale up. So in this case, we're scaling up this deployment here. We're telling it that we want to scale up a RabbitMQ queue, and then a little bit of configuration that's Rabbit specific there, and a little secret to say, a little secret reference there to say where the queue is. So with just a few lines of YAML there, then we can tell Kubernetes to scale up this particular container to the size that it needs to be to work off this particular message queue. Dapper, like I say, it's called Distributed Application Runtime, and it has a whole load of features, not all of which we really care about for what we're talking about here. But it allows you to talk from your service to another service, allows you to go and fetch secrets in a standard way, allows you to easily connect to all sorts of different output things. So, if you wanted to, connect to another service bus or to a database or whatever, it's got standard ways of doing that, and to caches and things. It's got PubScrub built in and state management as well. So if you actually have to want distributed state across all your containers, you can do that. But the main one it's got is this thing called an input binding. So again, we've got this workload here, this source of messages. And what Dapper can do is to watch that and automatically fire the information about what came into that workload to your container, to your code. And again, that's a very simple setup. You just tell it, in this particular case, connecting to a service bus or a message bus. So you just tell it what your connection string is, what the name of the queue is, and one or more little bits and pieces of configuration based on your particular implementation you got there. So BelfastJS, I'm going to go out on a limb and put some JavaScript in here. This is then all you need to do to actually run your serverless container. You just fire up any old HTTP thing, Express in this case, listen on the endpoint that you defined earlier in your configuration, and what you'll get here in the request body, thanks to Dapper, is your queue message, your SMS message, your email, your database row, whatever it is, that'll just get posted into you in a standard format in the request. So you can then go and do whatever you need to do. And if you want, you can also then use Dapper later on to fire out some more messages to get processed. But as you can see, that's pure HTTP. So the nice thing about this is when you're talking to Dapper and when you're running your stuff, you don't need to do anything other than have an HTTP server running. So I've actually done this sort of thing with literally with Fortran and had it working. So so if you're in this situation where you want to do serverless but your management won't let you do it using serverless, stick it on Kubernetes, add in some virtual nodes and virtual kubelets to allow you to run it directly on containers. Add in Kida so that you can start scaling, add in Dapper so that you can read and write from work that you're doing, implement an HTTP server in your code, and hey presto, you've got serverless node running anywhere. And I think I kept that relatively short.
Awesome. Thank you very much, Mark. It's very, very interesting. So if anyone has any questions, remember you can ask in the chat or unmute yourself and ask away. But there's a couple of kind of sent in. So does the additional DevOps cost outweigh not having a vendor lock-in? So I'm trying to think this example would be using something like Netlify versus building your own kind of containers and everything.
Yeah, I mean, it's always going to be a little more tricky. Nobody enjoys setting up Kubernetes. So yeah, it's not for everybody. But it is a nice easy pattern. So once you're set up, it's good. Worth knowing, if you happen to at least run on Azure. Azure has a thing called Azure Container Apps, which is all that. So it's actually a Kubernetes cluster with all the Keda and Dappen stuff built in, but it's got an extra layer of configuration at the top so that you don't need to care about any of that. So you can make an easy to configure serverless thing, but because it's already running on Kubernetes, you can actually pick it up and move it to any other Kubernetes cluster if you want. But you can at least start with something which is nice and easy to configure, and also is a lot cheaper because it actually doesn't literally allow you to scale down to 0. So if you want to get started on this, you can start with Azure Container Apps, and then if you can just tell the boss, well, because it's running on Kubernetes, if we need to move to AWS or GCP, then we can do that.
Yeah, because I was going to follow that question. If you built it on top of like a homegrown solution in Azure, like would you be able to move it to like AWS or that's only real too I can think of a different system? Yeah.
Oracle have a cloud and IBM have a cloud. Very common.
They just don't.
Alibaba, of course, Alibaba is very huge if you happen to be in China.
And then another one that came through as well. So is there any limitations whenever you are running in Kubernetes and containers to like JavaScript libraries or the ability to use like node modules? I've seen that you used Express in your example. Like, is there, can you use just everything you normally can use?
You can use, like I say, I've done it with Fortran. I mean, it's just containers. So as long as you can run it in a container, and as long as you can expose, as long as you can listen on HTTP, yes, you can use it. So
okay, awesome.
I did it. Fortran doesn't even have an HTTP library, but as long as you stick it behind a reverse proxy and stick a CGI bin endpoint on the end of it, then you're good.
I'm assuming this Fortran app isn't running in production with critical customers.
No, my aforementioned daughter is doing a PhD, and prior art for the stuff she's doing research into runs in Fortran. It's written in Fortran, so that's why I can do this.
Awesome. Very cool. Unless have any other questions from any other folks?
Everybody's front end and didn't even understand the first word of that, I bet.
Well, we've been using Kubernetes a lot recently, and it is kind of relegated to the backend, but backend isn't always Java and C#. Like backend's becoming like heavily node developed nowadays with like Next.js and all these kind of tools kind of getting some more prominence.
I think it's just a container orchestrator at the end of the day, so you can run anything in it. You can also run serverless stuff in it. So yeah, so if you are doing the Netlify thing, but you want to do that, sort of independent of provider, then yeah, it's a way of doing that.
Yeah, because and again, to your point as well, yeah, like if you are going from Netlify, you're locked into Netlify. If they suddenly change their prices and you want to move somewhere else, you're having to rewrite your code base and having to explain that cost.
Stick a static website in there and the serverless API behind it, and you're good to go.
Cool, awesome. Thank you very much, Mark. It's very interesting.